Hey guys, and welcome back. So this is the result and it's still going. It took 7 minutes now for this, and I'm pretty happy with the progress. I think there's a lot of details. The main thing that we need to work on is the stiffness. So you can see the particles. So look at this cluster, for example. Let me cancel this. If we look at this section here, as it goes, it's gonna it's basically staying the same. There's nothing happening to it, and there is a very uniform connectivity between the particles, and that's because the stiffness is constant. We also don't have any winds in the scene which would take over as these particles lose momentum, so that will drag them from left to right to add the wind that we saw in the reference. So let's first add the wind. Okay, so I'm going to create a geometry node. I'm going to call this forces, and I have an existing box I'm going to copy just for the domain. Come on. Okay, and I'm going to use a volume node. And I'm going to call this a vel. And it's a velocity field, it's a vector field, and I'm gonna change it by size, and let's set this to 1. We don't need a lot of details here. And now we have our volume field, and then I'm gonna use a volume velocity node. This will help us set, it's a new node in Houdini 17. It's gonna help us set the velocity on this guy. So let's create a grid that is inside, or you know what, I'm gonna do this. I'm gonna blast this face and then transform it to be inside this here, and I'm gonna scale it. Something like that, and I'll explain in a second why. I'm gonna scatter a bunch of points on this. I don't need relaxation, and let's not a vertex, let's add some curl, and let's use a volume trail node. This is gonna help us visualize. We need the input points first, and then the velocity field, so that's gonna be vel.star, and we can increase the length, and that's gonna show us how everything works basically. So let's increase this, and we also want a uniform force, so I'm going to set this to 2.5 along the z-axis. Sorry, it's negative 2.5 along the z-axis, and let me match the settings that Igor had in his scene. So it's quite a big noise, and then the pulse is gonna randomize it faster. So if we set this to 2, it's gonna change slowly. If we set this to 0.25, it's gonna change faster. And I think that's pretty much it. The next thing is we don't want, so right now if we use this force, it's gonna affect the particles that are the floor level, same as the one at the top. So we don't want that. We want to introduce some kind of velocity, height multiplier. So let's do this. Let's create a volume VOP. And we know the height. We know the height of our volume. Okay, so it's 70, and I'm gonna take the position and fit range the y between 0 and 70. That's gonna give us a 0 to 1 value. And then we want to use, we're going to import the velocity. So that's a vector. And we're just going to multiply it. Going to swap the inputs and export this as a vector again. And call it val. Set this to a vector. And you can see already it changed, and I'm gonna add a ramp so we can control this. And it's a float. spline ramp. Okay, let's go up. And we don't want it to be very linear. Set it to Bezier. Let's try B-spline on both. Something like that. Okay, so this is our force. So let's visualize this now. You can see we have variation. And we don't want any velocity here. So I'm going to set this to, I'm going to move this guy. So it's only the 3/4 here. And let's add a null. Call this out wind. I'm going to copy the node, which copies the path. And let's go inside. Now the trick is to treat these points as particles. And for that we're going to use a pop effect by volume. And I'm going to connect it to the velocity input, particle forces, and let's paste the path. I'm going to set this to update, treat as wind. I'm going to turn this off. I'm going to set the scale to 0.5 and I'm going to set this to 4.25. These are just values to match what I had before, what Igor had before, but there's nothing crazy about them. Just tweaking the amplitude so it looks correct the first go. And I'm going to lower this so it's faster to work for us. Okay, let's see. You see with the stiffness, with the what's called the constraint stiffness, it's much slower because we increase these points as well. But you can see the effect right away, and this is really nice. We have to increase the domain for the whitewater so it doesn't get clipped. And let's see. Okay, it looks like it's working, but I'm not seeing that. Yeah, it's working. I think it is working. Yeah, it's working. Okay, so here's what I'm gonna do. I'm gonna lower this to 20 and 40. I'm gonna set this to 1 and let's leave that, it's fine. I'm gonna increase this to 2. And so that we get a faster feedback. And I want to make sure that the force is working. Okay, it doesn't look like it's working, So I'm gonna pause, or it's working. Yeah, it's working. Nope, it's not working. So I'm gonna pause. Actually, I'll debug this and then we'll continue in the next video and we'll show what the solution is and what the problem was. Thank you guys for watching and see you in a bit.